Did you know that nothing, not even light, can escape a black hole's gravitational pull? Welcome to the intriguing world of black holes, quite possibly the most mysterious objects in the universe. Black holes are regions of space-time where gravity is so strong that nothing, absolutely nothing, can escape its clutches. They are like cosmic prisons from which there is no parole. But what is the origin of these awe-inspiring yet terrifying phenomena? They are born from stars, much like the sun we see every day. But these aren't your average stars. They are stars that have lived out their lives and exploded in a supernova, an event so powerful it briefly outshines an entire galaxy. The remains of these stars, if they're massive enough, collapse under their own gravity, creating a point in space where gravity is so intense, it forms a black hole. The black in black hole comes from the fact that not a single ray of light can escape from it, making it invisible against the dark void of space. Black holes are not just theoretical concepts, but real entities in our cosmos. We cannot see them directly, but we can observe their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will draw matter inward in a process known as accretion. This accretion disk heats up and emits X-rays, which we can detect and study from Earth. Black holes also have a profound effect on time, warping it in ways that are hard to comprehend. Time, as we understand it, stops at the event horizon, the boundary of the black hole. So, black holes are not just science fiction, but real fascinating objects in our universe. They challenge our understanding of physics, raise questions about the nature of time and space, and captivate us with their sheer power and mystery. As we continue to explore the cosmos, who knows what other secrets these cosmic behemoths will reveal? You might be wondering, what exactly makes up a black hole? Well, you're in for a treat. A black hole is a fascinating cosmic phenomenon, a region of space where the gravitational pull is so strong that nothing, not even light, can escape it. But what gives a black hole this extraordinary power? Let's break it down. First, we have the event horizon. This is the boundary of the black hole, the point of no return. Anything that crosses this threshold is sucked in, never to be seen again. The event horizon isn't a physical barrier, but rather an imaginary line, a point in space where escape becomes impossible. It's the defining feature of a black hole, and it's what makes them, well, black. Next, deep within the black hole, we find the singularity. This is where the magic, or rather the science, happens. The singularity is a point of infinite density, where all the matter sucked in by the black hole is crushed into an infinitesimally small point. It's here that our understanding of physics breaks down, and the laws of the universe as we know them seemingly cease to apply. Now, surrounding the black hole, we have the accretion disk. This is a swirling whirlpool of gas, dust, and other materials spiraling into the black hole. It's heated to incredibly high temperatures by the immense gravitational forces at play, causing it to glow brightly. This is why, despite black holes themselves being invisible, we can still spot them in the cosmos. They're betrayed by the brilliant light of their accretion disks. Finally, let's not forget about the jets. Some black holes shoot out streams of plasma, known as jets, from their poles at nearly the speed of light. These jets can stretch for millions of miles into space, further adding to the mystique and majesty of black holes. These components make black holes the powerful and mysterious entities that they are. So, next time you gaze up at the night sky, remember, somewhere out there, black holes are bending the very fabric of space-time, playing by their own rules in the grand cosmic game. If black holes are invisible, then how do we know they exist? Ah, the cosmic conundrum that has piqued the curiosity of many a stargazer and scientist alike. Let's delve into the methods that have been devised to detect these enigmatic entities known as black holes. First off, it's crucial to understand that while we cannot see black holes directly, we can observe their effects on nearby matter and light. Picture a black hole as a whirlpool in the vast ocean of space-time, invisibly pulling everything around it into its vortex. One method scientists use to detect black holes is by observing high-speed jets of particles being spewed out into space. These jets, also known as astrophysical jets, are thought to be launched by the incredibly strong gravitational pull of black holes. When matter gets too close to a black hole, it forms what we call an accretion disk, spiraling in at high speeds and emitting intense radiation in the process. Another way to detect black holes is through the phenomena known as gravitational lensing. This is essentially a cosmic illusion where the gravity of a black hole bends light around it, causing distant objects to appear distorted or magnified. It's like looking through a funhouse mirror, but on a grand cosmic scale. Lastly, scientists also use the detection of gravitational waves to identify black holes. When two black holes collide, they create ripples in spacetime, much like the ripples created when a stone is thrown into a pond. These ripples, or gravitational waves, were first predicted by Einstein's theory of general relativity and have since been directly observed by the LIGO and Virgo collaborations. So, while black holes themselves may be invisible, their effects are not. Their gravitational influence, the high-speed jets they launch, the distortion of light around them, and the gravitational waves they create all serve as cosmic breadcrumbs, leading scientists to their existence. Observing these phenomena allows us to detect the presence of these invisible, yet impactful, black holes. And while we may not be able to see black holes directly, these methods provide us with a window into the intriguing world of these cosmic enigmas. Black holes are more than just cosmic oddities, they play a crucial role in our universe. Imagine a cosmic ballet, where galaxies are the dancers and black holes the choreographers. Black holes are instrumental in galaxy formation. The supermassive black holes, often millions of times the mass of our sun, reside at the heart of galaxies. Their intense gravitational pull influences the motion and formation of stars, helping to shape the galaxy. But it's not just about the structure. Black holes also contribute to the evolution of galaxies. When matter falls into a black hole, it doesn't disappear quietly. It emits energy in the form of radiation, with some of it escaping into the surrounding galaxy. This radiation can trigger the birth of new stars or, if intense enough, suppress star formation by heating and dispersing the gas clouds where stars are born. Now, let's venture into the realm of the unseen dark matter. We know it's there because of its gravitational effects, but what exactly is it? Some theories suggest that dark matter could be made up of primordial black holes. These are black holes that could have formed in the early universe, long before stars began to shine. If this theory holds true, it would mean that black holes are not just the architects of galaxies, but also the hidden scaffolding of the universe. However, it's not all about creation and construction. Black holes are also the universe's ultimate recyclers. They take in matter, grind it down, and spew out energy. This energy can then trigger the birth of new stars, completing the cosmic circle of life and death. Black holes are like the universe's Swiss Army knife, multifunctional and indispensable. They build, they destroy, they recycle, and possibly, they hold the key to one of the universe's greatest mysteries. So, while they may seem destructive and chaotic, their existence is essential to the cosmic order. Black holes, though destructive, are key players in the grand scheme of the universe. Scene script: have you ever thought about time travel? Black holes might be your best bet. Now let's dive into a concept that has intrigued physicists and science fiction writers alike for decades. Time dilation around black holes. Time dilation is a difference in the elapsed time measured by two observers, due to a velocity difference relative to each other, or to a gravitational field difference between their locations. And when it comes to black holes, time dilation takes a fascinating twist. Imagine you're watching a clock as it approaches a black hole. From your viewpoint, the clock appears to tick slower and slower the closer it gets to the black hole. This is not some optical illusion or faulty timepiece. It's the very fabric of time itself stretching, warped by the intense gravity of the black hole. This phenomenon of time dilation is a central component of Einstein's theory of general relativity. It's the idea that gravity can bend not only the path of light and physical objects, but the trajectory of time itself. Now, what's happening inside the black hole, you might ask? Well, that's where things get really interesting. Theoretically, as an object crosses the event horizon, the boundary of the black hole where escape becomes impossible, time and space essentially swap roles. Inside the black hole, the forward march of time becomes a plunge toward the center. But don't pack your time travel bags just yet. It's important to note that these are currently untestable theories. Even if we could safely get near a black hole, the intense gravitational pull would rip apart anything that comes too close, a process gruesomely known as spaghettification. So, while black holes could theoretically serve as portals to other times, they're not exactly hospitable destinations, but their existence and the scientific exploration they inspire continue to challenge and expand our understanding of the universe. It seems black holes not only warp space but time itself. From time travel to interstellar shortcuts, black holes might be gateways to wormholes. Let's dive into the realm of the purely theoretical. a concept that has tantalized scientists and science fiction writers alike: wormholes. Wormholes are essentially bridges or tunnels imagined by the laws of physics that could connect two distinct points in space-time. Now imagine if these points were not just separated by distance but by time itself. Sounds like the stuff of movies, right? But this is the world of quantum physics, a world where the impossible often becomes probable. So how do black holes fit into this? Well, the immense gravity of a black hole warps the fabric of space-time around it. Some theories suggest that at the heart of a black hole, this warping becomes so intense that it forms a tunnel to another point in space-time. A wormhole. However, before we start planning our time-traveling vacations, it's important to note that these are purely theoretical constructs. There's no hard evidence that wormholes exist, let alone that they're connected to black holes. Even if they do exist, wormholes wouldn't be the interstellar highways we imagine them to be. They would be incredibly unstable, prone to collapse at the slightest disturbance. Some theories propose that exotic matter, a type of matter with negative energy, could be used to stabilize a wormhole. But again, this is all theoretical. We have yet to discover or create exotic matter. Despite these challenges, the concept of wormholes continues to inspire. They represent a potential solution to one of the greatest challenges of space exploration: the vast distances between stars. If wormholes do exist and can be harnessed, they could provide shortcuts through space-time, making interstellar travel a reality. Wormholes are still purely theoretical, but who knows? Perhaps one day we'll use black holes for interstellar travel. For now, we continue to study, to learn, and to dream. And who can say what discoveries the future may bring? We've come a long way in our understanding of black holes, but there's still much to learn. As we step into the future of black hole research, we're carrying a torch of curiosity, fueled by the mysteries these cosmic entities hold. The journey ahead is lined with promising prospects and fascinating research avenues. One such avenue is the study of gravitational waves. Albert Einstein, in his theory of general relativity, predicted these ripples in the fabric of space-time caused by intense gravitational interactions. And guess what? Black holes, with their immense gravitational pull, are prime candidates for creating such waves. In 2016, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made headlines when it detected gravitational waves from a pair of merging black holes. This was a massive leap forward in astrophysics, allowing us to study black holes in entirely new ways. Now, we're not just relying on light or other electromagnetic waves, we're tapping into the very tremors of space-time itself. But the future of black hole research isn't just about studying these cosmic monsters from afar. There are also theories that suggest black holes could be gateways to other universes or dimensions. While this might sound like a plot straight out of a science fiction novel, remember that not too long ago, black holes themselves were nothing more than a theoretical curiosity. So, what's next on the horizon? Well, we're refining our tools, sharpening our theories, and venturing further into the unknown. We're building more sensitive detectors to catch gravitational waves, developing better simulations to model black hole behavior, and even planning missions to capture more detailed images of these cosmic beasts. The future is ripe with potential. With every new discovery, every new observation, we peel back another layer of the cosmic onion, revealing more about the nature of our universe and our place within it. The study of black holes is a journey into the unknown, and who knows what exciting discoveries lie ahead. As we delve deeper into the cosmos, we carry with us a sense of wonder, a thirst for knowledge, and the understanding that our journey is just beginning. So, we've taken a deep dive into the enigmatic world of black holes. We've traversed the intriguing dimensions of these cosmic phenomena, understanding their nature and anatomy. From the event horizon to the singularity, each component paints a picture of an entity that defies our comprehension. We've delved into how we detect these invisible cosmic beasts, using innovative techniques and technologies. We've also explored their significant role in the universe, influencing the formation of galaxies and the evolution of stars. Our journey took us through the corridors of time, revealing how black holes warp time itself, and even ventured into the realm of wormholes, a potential yet speculative offshoot of these cosmic entities. Looking ahead, we've seen the promising future of black hole research, offering tantalizing possibilities for new discoveries and breakthroughs. Black holes continue to be one of the universe's greatest mysteries, captivating the curiosity of scientists and space explorers alike. Until next time, keep exploring the wonders of our universe.